Today we will be working with systems still, but now we have inequalities. So there is just a slight difference, and basically it's a sign. Instead of seeing an equal sign, you will see an inequality sign. So a linear inequality describes a region of the coordinate plane that has a boundary line. And the solution of an inequality are the coordinates of the points that make the inequality true. So again, it's just the point that will work in both of the statements, and in this case, instead of being equations or inequalities is the only difference, but it still has to work in both equations. If we look at these ones that we have down here, we have y is greater than x plus 1. Because this is only a greater than sign and there's no equal to part, our line is a dashed line. Anytime it's a dashed line, that means the point on the line are not a solution. The only solutions to this inequality are the ones in this pink shaded region. So there is one more step you have to do besides graphing the line, is to graph. You will have to shade in the portion that works. Over here we have a solid line, and the reason we have a solid line is because this is less than or equal to, so that means the points on the line are part of the solution set. So let's go ahead and let's take a look at solving our first inequality here. Example 1 is just 1, so it's not a system, it's just a regular inequality. And it says y is less than 2x plus 3. So the first thing you need to notice, there's no equal to part. So your line that you're going to draw is going to be a dashed line. In order to graph this, I'm going to use my b at positive 3. And then I'm going to use the slope of 2 over 1 and go up 2 over 1. And now we can connect that, and like I said before, you need to make sure you connect yours with a dashed line. I'm going to have to make mine a dashed line after I draw it because I'm not sure how to get a dashed line using this tool. So there is my line, and I'm going to make it dashed. Maybe, there we go. I'm going to put my dashes on it so that everybody will know that it's a dashed line. Because it's a dashed line, none of the points that lie on this are part of the solution set. So 0, 3 is not part of the solution set. The other thing that I need to make sure that we do when we graph these are you have to extend your line clear out so that you can really get a detailed portrait of the solution set. Okay. So once you have the line drawn, then you have to decide which side of the line to shade on. I always check the point 0, 0 unless it's on the line. So if I plug in 0 here, is 0 less than 3? In this case, 0 is less than 3. So the points on the side of 0, 0 make this statement true. So we shade on the side over here. So basically that's saying any point on this side is part of the solution set. So if I just check a few of them, let's say I want to check the point 5, 0. If I plug 5, 0 in, is 0 less than 13? Yes, it works. So as you can see, any point over here that you try will be a solution. Okay, let's go ahead and let's look at our next example. Let me make this a little bit smaller so we can see the whole coordinate grid here. There we go. Okay, again, we are just doing a linear inequality, so we're not doing a system yet today. That will be in tomorrow's section where we do a system of them. So in order to graph this one way you can graph it is you can rewrite it, the inequality to be in y equals mx plus b form. If you do that, remember, if you multiply or if you divide by a negative, you have to flip the sign. So I'm going to show you that method just in case you want to use it. Otherwise, you could use just this standard form and use your intercepts or get 2 points. So if I want to rewrite this, I have 3x minus 5y is less than or equal to 10. I'm going to subtract 3x minus 3x plus 10. I now need to divide by negative 5. Since I'm dividing by a negative 5, I have to remember to flip my inequality sign. Negative 3 divided by negative 5 is 3/5 x. Positive divided by a negative is a negative. 10 divided by 5 is 2. So my equation rewritten looks like this. Because I have an equal to part, I'm going to have a solid line this time. So I'm going to go ahead and, actually I'm not going to make a t-chart because I'm just going to use my slope and my y-intercept. So my y-intercept this time is negative 2. My slope is 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. It's a solid line this time, so I don't have to worry about dashing it once I'm done here. But I do need to try to make sure it goes on past all the coordinate parts here, so I can make sure my shaded region is correct. Now to shade it, I'm going to again try the point 0, 0. 0 is greater than or equal to negative 2. 0 is greater than 2, so 0, 0 does work. So since 0, 0 works, I can shade any part on this side of the line. And that's my solution set. So what makes the difference between an inequality and an equation is that the solution set is much larger because it can be any point on this side, and in this case it could also be part of the line. In an equation, your solution set is just where the line is located. Okay, our next example here is a real world problem. Suppose your budget for a party allows you to spend no more than $12 on peanuts and cashews. Peanuts cost $2 a pound and cashews cost $4 a pound. Find 3 possible combinations of peanuts and cashews you can buy. I'm going to say P stands for peanuts, C stands for cashews, $2 for peanuts plus $4 for cashews, and I can only spend $12. And I'm going to make C and then P because I'm going to go in alphabetical order, just like my X and my Y. Make sure you don't think that's 14 now. My pen kind of jumped over there. So this is the pounds of cashews. And then these are my pounds of peanuts. And I just chose C across the bottom to put it in alphabetical order, just like X and Y. Okay, now I'm going to get some points here. Let's just see if we can use our intercepts. Remember, we have C and P are our X and Y. If I put 0 in here, I get P is equal to 6. If I put 0 in for P, I get C is equal to 3. Okay, so now I'm going to go ahead and graph those. Since my numbers are little, my scale has to just go up by 1. So 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. So 0, 6. And it says, suppose you're no more than $12, so I forgot that part. Since I can't spend more than $12, I need to go less than or equal to 12. So again, I'm going to have a solid line. And my solid line is going to go from there to there. Okay, and now I need a shade in. If I put 0 in there, 0 is less than or equal to 12. Yes, 0 is less than 12. So any combination on this side would work. And they said that they wanted 3 possible combinations. Well, the 3 possible combinations I'm going to use are 2 pounds of peanuts with 2 pounds of cashews. I'm going to use 4 pounds of peanuts and 1 pound of cashews. And then the last one I'm going to use is 1 pound of peanuts. And I'm going to use 2 pounds of cashews. And then we'll look at these combinations and I'll show you why they work. So if I look at these combinations to see why they work, 2 pounds of peanuts, 2 pounds of cashews, 2 and 2 would be right there. In this case the line does work because it's equal to part. 4 and 1, and I have 4 pounds of peanuts and 1 pound of cashews. Again, that's on the line, so it works. This next one though is not on the line, but it's in the shaded region, and so that's why that one works. Go ahead and complete your quick checks for this section, and then look at your schedule to find out your assignment.